In this video, I will demonstrate how to position a point in cylindrical coordinate system. Before drawing, let's talk a little bit about cylindrical coordinate system. In cylindrical coordinate system, a point is positioned in such a way that it goes on the circumference, or it is situated on the circumference of a cylinder with radius rho, height z, and the specific position on the cylinder is denoted by phi. So these are the three properties that is expressed in cylindrical coordinate system. Let's talk a little bit details about these three properties. First, rho. Rho is the distance of the point from the central axis. Now phi. Phi is the angular position of the point from x-axis. That is angular displacement of the point from x-axis, and z is basically the central axis, so this actually denotes the height. Okay, now let's talk a little bit more about these three properties or three parameters. So to understand it more clearly, let's take a point in a three-dimensional system. Suppose this is a point in a three-dimensional system. Suppose the axis, we set this axis as x, so consequently this will be y and this will be z. To understand rho phi z clearly, let's take the interpretation that we described earlier for this point. So the first one is rho. So rho is the distance from the central axis. So in this figure, we can see that z is our central axis. So rho should be the distance from this z axis, right? So let's take it. So to have this distance from z axis, let's rotate the ruler. Suppose this is the distance from central axis. So this is rho. So this distance, what we have taken right here, is our radius of the cylinder, rho. Now what about phi? To have phi, we have to take projection of this point on the horizontal plane. We have to take the projection on horizontal plane. So let's take projection. To have projection, we have to place our ruler at this point and make a line parallel to z-axis. Make a line parallel to z-axis. I think 90-degree will be necessary here. So let's take a 90-degree line. That is a parallel line with respect to z-axis. Now to have the proper projection, we have to draw a line from origin that will be parallel to our rho line. So we have to take a line that has to be parallel to our rho line here. So let's rotate our ruler. I think this is quite parallel. Yes, this is parallel, right? So let's take a line that has to be parallel to the rho line. Fine. Now what is x? What is phi? Already we have defined it, that phi is the angular distance of this point from x-axis. So phi is the angular distance of this point from x-axis. So this is the angular displacement. So this is phi. Now what about z? Z is the height along the central axis. So basically this height is z. Okay, now let's apply our concept that we have learned so far to position a point in cylindrical coordinate system. So first, consider a point. Suppose our intended point is P, whose coordinate is 1, pi by 3, which is 60 degree, and 2. So yes, now we know that here 1 is rho, the first coordinate is rho, the second coordinate is phi, and the third coordinate is z. So let's place it in a three-dimensional system. Let's take a three-dimensional system and place the axis. So of course, how we have named here, Z should be our central axis. So Z is our central axis. So consequently, this axis will be X and this axis will be Y, right? So now what we will do is that first we will draw the projection of this point on the horizontal plane, which is on XY plane, and then we'll include the height. And this procedure we also followed for Cartesian coordinate system. To draw the projection, first we will include rho, and we know that rho is the distance from the central axis. But as we are trying to draw the projection, so the point of central axis on the horizontal plane will be origin. So we have to take the rho from origin. So suppose this is our origin, and we have to take a 1 unit length line from origin. So let's take a scale and place it. Now the question is how we have to draw this 1 unit line from origin. We have to draw in such a way so that it makes an angle phi with x-axis. So we will draw this 1 unit line, or better, draw it with a dotted line. That will be much convenient to understand. So we have to draw this 1 unit line in such a way so that it makes an angle phi with the x-axis. So it will make the angle pi by 3 with x-axis. Alright, so this is our 1 unit line, and it has made it has made 60-degree angle or pi by 3 angle with x-axis. So from here we can say this is our projection point. So here this point has rho 1, this point has phi pi by 3, but it has no height, so height will be 0. To include the height, what we need to do is that we have to place the scale at the projection point and then draw a line that will be parallel to z-axis. So let's place the ruler at the projection point and make it parallel to z-axis, that is at 90-degree angle. So yes, this is a good 90-degree. So let's place it and draw a line that will be parallel to z-axis. Now from z-axis our height is 2 unit, so we have to take a 2 unit distance or intercept along z-axis. So let's take a 2 unit. Suppose this is 2 unit. We're taking in a relative way, not exact measurement. So now to ensure that our point has 2 unit height, what we need to do is that we have to place the ruler at the z-axis intercept and draw a line that will be parallel to our projection line. So let's draw a line that will be parallel to our projection line. Okay, I think this is parallel to our projection line, right? So this is parallel to our projection line. So let's draw a line that will be parallel to our projection line. These two lines where it gets intercepted is our intended point P. That means whose rho is 1, whose angular displacement is pi by 3 with respect to x-axis, and whose height is 2. Okay, now let's talk about the vector representation. So in cylindrical coordinate system, if the point is P, then its position vector will be denoted by OP, and it will have 3 directions. One is radial direction, arrow. Another one is angular direction, which is a phi. And last but not the least is height direction, that is AZ. And they will have their magnitude. Like suppose our radial distance is rho, our angular distance is phi, and our height is z. So the point we are working with, that will have the vector representation as 1 a rho plus pi by 3 a phi plus 2 az. Now let's talk about the individual direction or the direction strategy for cylindrical coordinate system. First, talk about rho. So if we want to consider rho, we know that rho is the distance from central axis. So if something is coming out of the central axis, then rho will be positive, and something is going inside the central axis, then rho will be negative. So what is the strategy? If something is coming out of the central axis, then rho will be positive, and if something is going inside the central axis, then rho will be negative. What about phi? If something is rotating or going counterclockwise, then a phi will be positive, and something is going clockwise, then a phi will be negative. What about z? For z, it is the previous way, that is, if something is going up, we'll say az will be positive. On the other hand, if something is going down, then az will be negative. Now let's place this direction in our vector. So for our vector, the radial direction or the first parameter is positive. So the vector will coming out, its radial direction will be pointing outward from the central axis, which is z-axis, a rho. So here the second parameter is also positive, that is phi is also positive. So it will have counterclockwise direction, so its a phi will be in direction counterclockwise. And its third parameter, that is z, is also positive, so it will point upward. So these are the individual direction. To have the total direction, the usual procedure is that you have to add this P point with origin and take a vector direction which will come out of the origin. So let's rotate the ruler to draw this or connect these 2 points. All right. So let's connect these 2 points. I think not good enough. Not far good enough, right? Okay. So let's connect these 2 points and place a vector which will come out of the origin. This is our representation of a vector in cylindrical coordinate system. Hope you have understood well. Thank you very much.